Hello everyone. In this video we will understand the one of the important topic, that is what is meant by time complexity and space complexity of algorithms. So basically I have given you a brief idea about time and space complexity of the algorithm in our previous video. So in this video we will understand more formally what is meant by these terms. Okay. So this is very important topic, and in the upcoming videos we will understand more examples based on time and space complexity, that is how we can calculate the time and space complexity of the various algorithms. Okay, so I will give you various examples and various angles by which you can understand this concept very easily. Okay, so let's start. So basically, in simple sense, time complexity and space complexity are two ways in which we can analyze our algorithm. Okay, or you can say we can analyze the efficiency of our algorithm. Okay, so one can say we can analyze the efficiency of our algorithm in two ways, uh, in with respect to time and with respect to space. So when we are analyzing the you can say algorithm complexity with respect to time, then we will say we are calculating the time complexity of that given algorithm. Okay, and when we are analyzing the efficiency of algorithm with respect to the space, then we are saying we are finding the space complexity. So basically time complexity, this tells that how much time will be taken by our algorithm to give the output. Okay, so basically here you have to remember one term, that is CPU time. Okay, time complexity is related to the CPU time, that how much time will be taken up by our algorithm when our code executes on the CPU. Okay, and when we express the time complexity, we will express the time complexity in terms of the input size. Okay, we'll see in the further part of the video. Same way, space complexity is related to the main memory. Okay, so it tells that when you are writing a program, then you have taken some extra space. Okay, extra space, then how much extra space you have taken in your code, okay, to solve your problem. Okay, so that extra space, okay, which is actually taking the space into your main memory, so how much that extra space is there which is taken by your algorithm, so that will account or contribute towards the space complexity. Okay, so that is space complexity, how much extra space have been taken by your program other than your original input. Okay, so again, space complexity is also expressed in terms of the input size. Okay, so let's understand one by one the meaning of each and how we can actually find time and space complexity. Okay, so for example, you are given this array. Okay, and in this array you have to search a particular element. Okay, you have to search that whether a particular element that the user wants to find is present in this array or not. Okay, so one of the simpler algorithm that we can use to search a number in our given array or collection of element is linear search. Okay, so this is the linear search code. Okay, so I hope you know that how linear search algorithm actually works. Okay, so if you do not know, then you can find the link of this algorithm in my algorithm playlist. Okay, you can find the link in the video description below. Okay, so linear search is actually a searching algorithm which actually search for a given element in your given collection of, okay, elements. Okay, or you can say in your array. For example, I want to search this element. Okay, so let's say this is my key element. Okay, this is my key element, and this is my given array. Okay, this is my given array, and n is the size of this array. So currently here there are 4 elements. Okay, or I can say my array size is 4. Okay, my array size is 4. So in this given array I want to search my key element, that is 15, whether 15 is present in this array or not. Okay, so if my element is present, then I am returning true. Okay, if my given key element is not present in my array, then I am returning false. Okay, so somebody gave me this code, okay, this linear search code, and they are asking, okay, tell me the time complexity of this given algorithm. Okay, so in simpler sense they are asking how much time will be taken by this function or this code, okay, on the CPU to give us the output, and output is true or false. Okay, that is whether the element is present in the array or not. Okay, so in how much time this answer will be given by your algorithm. Okay, so as we know how linear search actually works, so it's actually scan through each of the element in your array, and it checks each and every element, okay, to find your key element. Okay, so it will say, okay, my key element is equal to this 0th element, that is 5 or not. I will say no. Now 15 is equal to this 1th element, that is 8. No. 15 is equal to this my second element, that is 10. No. Now 15 is equal to my third element, that is 15. I will say yes. So here I will return true. Okay, I will return true. So in my for loop, okay, I am again and again checking if my a of I means I equal to 0, I equal to 1, I equal to 2, I equal to 3. Okay, if these elements are equal to my key element is 15. Okay, so when this condition become you can say true, then I am saying returning true. Otherwise, I am just going over and over in this loop. Okay, now it can also happen my element may not be present in my array. Okay, so for example, if I want to search my key element, let's say is 100. 100 is not present in this array. Okay, then also how many times I have to scan this array? So basically I have to again scan from 0, then 1, then 2, then 3, and after that my array is like you can say array is finished. So I will say return false. Okay, because my for loop will be false. Okay, and then I will return false. Okay, so now if you see that if my n is 4, okay, and my element that I want to search, it can be at any place. Okay, it can be at the last position, it can be at the first position, and it can be in the middle of this array, right? And the another scenario can be my key element cannot be present in my given array. Okay, this element does not exist in my array. Okay, so actually when somebody is asking you about the time complexity and space complexity also, okay, so when somebody is asking that tell me the time complexity, then in general they ask you tell me in worst case how much time it will take for your algorithm to give us the output. So let's take an example to understand this worst case. Okay, so basically let's say if you want to move or if you want to go from Dehradun to Delhi, okay, by bus. Okay, so somebody wants to give you the money. Okay, then how much money he should give? Okay, now this is the problem. Okay, so for example, if you go via ordinary bus from Dehradun to Delhi, let's say fare is 300. If you go by deluxe bus, then it is 500. If you go by Volvo bus, then it is 800. Okay, so these are the fares. Now how much money will you take in your pocket if you want to move from Dehradun to Delhi by bus? Okay, so you will say, okay, in worst case it can happen that if you go on the Dehradun ISPT, then there is no ordinary bus, there is no deluxe bus. Okay, only Volvo is there. Then in worst case this thing can happen, right? So you will be prepared for the worst case scenario. You will say, okay, give me 800 rupees. Okay, give me 800 rupees, although you will not like take exact 800 rupees, you will take more. Okay, for eating and other purpose. Okay, well, let's say you will take this 800. Okay, because on max, okay, on max your Volvo can be present. Okay, nothing can be present, only Volvo is there, so 800 will be like a good amount so that you can go from Dehradun to Delhi, right? So this is the worst case. Okay, worst case means at max. Okay, what can happen? Okay, at max, okay, you will prepare for the worst scenario. What is best case? Best case scenario means minimum. Okay, what does minimum mean? In best case it can happen that ordinary bus is there. Okay, so you take the ordinary bus and you can just go from Dehradun to Delhi in 300 rupees only. And average case means like you find deluxe bus. Okay, so you can take 500 rupees. Okay, so in general in life we actually prepare for the worst case. Okay, we do not prepare ourselves for the best case. Okay, because if we are prepared for the worst case, then we can handle the best case. If we have 800 rupees and luckily we go on the Dehradun SPT and we got 3 on the ordinary bus, then it is okay. Okay, we can just spend 300 rupees and we are left with 500 rupees in our pocket, right? So this is meant by the worst case. Now same thing happens in our algorithms also when we analyze their complexities. We say that at max how much time it can be taken by your code to give the output. Okay, so if you see here, if n equal to 4, that means the size of the array is 4. Okay, this was my input. Okay, this array is my input. Okay, where n is denoting the size of the array, right? So if n is equal to 4, okay, so in worst case I can say my element that I want to search, it is at the last position. Okay, then if I want to search 15, how many comparison I was doing. So here if you see I equal to 1, I less than n. Okay, so for the first time I will say, okay, I less than n, I am checking. Okay, 1 less than equal to 4. Okay, then I am coming inside, then I am checking this. Okay, I am checking this. Okay, for the first time I check this. Okay, I check this also. Okay, now this is false because a of 0, that is 5 is equal 15. No, then I'm again going I plus plus. So I plus plus is done for the first time. Okay. Now I less than n. Again, this is compared. So we will say second time this statement is compared, right? Okay. Now this is true, okay, because 1 is less than equal to 4. Again I will check, okay, a of 1, that is 8 equal to this 15, no. Okay, so second time I check this condition. Again I will go there, okay, and I will do I plus plus. So again, now second time I am doing I plus plus. Okay, now again I will check this condition, that is 2 less than 4. Okay, yes. So third time I'm checking this. Okay, now again I'm coming inside and I'm checking this, whether my 15 is equal to 10, no. Okay, so third time I'm checking this. Now last time I plus plus 3. Okay, 3 means I'm third time I'm checking this. Now 15, oh sorry, I is what, index 3, n is 4, 3 is less than equal to 4, yes. So fourth time I checked this condition. Okay, I checked here, 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 now here. Okay, fourth. Again I came here. Now a of I is 15. Okay, 15 is equal to 15. Yes. So I check this condition and then I'm returning true and then I'm going. Okay. So my true is returned after how much time? So if I see this thing is checked how many times? 4 times. Okay. Then this thing is checked how many times? 3 times. And this ai equal key, this comparison is done how many times? 4 times. The more the number of value of n, okay, more the value of n is, the more number of times this for loop will happen, okay, or execute. These things are dependent on n, right? Even my number is present at the last. Okay, so for example, if my array contains, okay, let's say many numbers, okay, 5, 8, 10, 15, 70, okay, 100, and I want to search this element. Okay, so here how many element are there? 3 and 3, 6 element. Okay, so I want to find 100, that is the sixth element. So at that time this loop will run, okay, more number of times, not 4 or 5 times. Okay, it will run 6 or 7 times. Okay, now the same thing here. Okay, so basically what I want to tell you is, here my execution of this code is dependent on value of the n, how large the my array is there. Okay, so if you talk about in terms of n, then what, how many number of times this I less than n is being executed. Okay, so in this case this is executed n times. Okay, like 4 times. This is executed n minus 1 time, like 3 times. For n equal to 4, this execute n minus 1 time, and this ai equal to 4 times, that is n times. Okay, so if you see, this is n n n 3n minus 1. Okay, so in this way I can say my time complexity, okay, time complexity, tc means time complexity, is 3n minus 1. So as I told you in my first slide, that time and space complexity are expressed in terms of function of input size. So whatever we are giving the input, in terms of that we will express the time and space complexity. So if you see here, my input is n. This key is also input, but this key will not affect, okay, this time, because even if key is 100 or any element, okay, it will not affect it how many times this for loop will like execute. Okay, who is deciding that how many times this for loop will execute? This n. Okay, the larger the value of n, larger number of times this for loop can execute in worst case. Okay, so I will say time complexity in terms of my original input, that is n, is equal to this is my time complexity. Okay, we do not actually express our time complexity in this form, okay, 3n minus 1. Okay, basically what we do is, here you can see these are the rules which we follow when we are expressing our time complexity. We discard the constants, okay, which are in addition, subtraction, multiplication, or division. So here you can see this minus 1, okay, this, or you can say this 1 is a constant, right? So we will actually discard this. Okay, we will actually discard this, so we will be remaining with 3n, because in, if you like increase the value of n, let's say n is 1000, then this will be 3 into 1000, 3000. So in terms of, you can say this value of n is 1000, this one is very much smaller. Okay, so we can remove these smaller terms also. Okay, this 3 is in the division, we can also remove this 3 also. Okay, because let's say n is, let's say n is 10 to the power 5. Okay, so if we remove this 3 also, then also it will not affect, okay, so much. So basically we will be left with n. Now we will say time complexity is n. Now I will tell you in the further video that we actually express in form of order of n. This is known as big O. So this is known as time complexity is order of n. okay, or you can say time complexity is order of n, okay, in this way. Now even if my number is not present in this array, then what would have happened? Then this loop would be running one more number of times, right? Instead of 4 times, this will execute one more number of times, right? So in that sense, here it will, for n equal to 4 only, if my number is not present, then in worst case, then it will execute how much time? 5 times. Okay, how many times this instruction or this I++ will go on to the CPU? This will happen 4 times, one more times. Okay, so 4 times plus this will happen 5 times. Okay, that means this comparison instruction or I++ will go or execute on the CPU this number of times. So basically one more number of times this thing is happening. That means in terms of n, okay, this is occurring n plus 1 times, this is occurring 4 times, and this is 1 greater than n plus 1 time. Now if we add, so 1 2 3 3n plus 2. Okay, now if we go by the rule, okay, this rule says you can remove the constant in addition, subtraction, division. So addition is plus 2, we can remove. Now in multiplication we have this, okay, so we can remove this, so we are left with n. So basically we will not say our time complexity is 3n plus 2. Okay, we will express in this way, time complexity in terms of n is order of n. That means the time taken by this code to give us the output, that is true and false, is varying with n with this order. Okay, and if you talk about the mathematics, we can say this is basically function, okay, function of n equal to this is n. So you know this is a linear function. Okay, so linearly my time is increasing or changing, okay, for this code. Okay, this is meant by this. Okay, so if your n is, let's say, 100, okay, then f of 100 will be 100, then means 100 unit time of will be taken by this code to give the answer. If my n is 200, then f of 200 will be 200. That means 200 unit time will be taken by this code to give the answer. This is meant by the time complexity. Okay, I hope you got the idea that what is meant by the time complexity and what are the rules we have to follow. Okay, the meaning of this term I will tell you in the further videos, okay, when we will take more examples. Okay, now one more example before going to the space complexity. For example, this is a sorted array, okay, and I want to search a particular element in the sorted array. So you know, to search an element in a sorted array, we have binary search algorithm. Okay, so in this given array which has how many elements? 10 elements, I want to search 30. Okay, so I hope you know how binary search algorithm actually works. So if you do not know, please watch the binary search video. Okay, you can find a link in the video description below. Okay, so I will not actually tell you that how binary search actually works code wise and all. Okay, this is just for the example. Okay, now here also n is the input. Okay, and this n can vary. Okay, it is showing the size of the given array. Okay, now if you see, element to search is 30. Okay, 30 is here. So how binary search actually works? So it actually find the first mid position, right? Mid position you can say low plus high by 2 or low plus high minus low by 2. Okay, it is like one and the same thing. Okay, this is just for taking the overflow into the consideration. Now then we check, okay, the middle element is equal to my key element. If it is, then we return true. Otherwise we check on the either right side or the left side. Okay, so if we say okay, if my key element is lesser than a of mid, then we move on the, you can say, left hand side. Okay, otherwise we move on the right hand side. Okay, so here how many number of comparison will happen? Okay, comparison means how many times this thing will execute, basically this low less than equal to high. Okay, how many times this loop will be executed. Okay, so I want to know time complexity in terms of n. Okay, what will be the order? Okay, so basically the midpoint of 0 plus 9 by 2. Okay, 9 by 2 is 4.5, so I will take 4. So 4 is mid position. So my 30 is not equal to 22. Okay, so I will come here. Now I will say my 15. Okay, key element 15. It is greater, sorry, less than a of 4, that is 22. I will say, sorry, key is 30. Now 30 is less than a of 4. 30 is less than a of 4. No, 30 is greater than. Okay, so I will come here. 30 is greater than a of 4. Okay, so I will say low is equal to mid plus 1. So my low is here and high is here. So I will search here, right? Now I will find the mid of the 5 and 9. Okay, so 5 plus 9 by 2, it will be 14 by 2, 7. So my mid is this one. Now before going this, see, one time comparison I had done. Okay, when I was first entering and I was calculating this. Now second time again I did the comparison and I found this. Okay, okay. Now if you see, my 15 is not equal to this, right? So I will say, now I will come here. Now sorry, my 30 is not equal to this, so I will come here. Now my 30 is lesser than 28, I will say no, so I will go this side. Okay, now again for the third time I will do low less than high. Okay, my low has come here, high has come here. Now again I will find the mid. Okay, so 8 plus 9 by 2 is 17 by 2, which is actually 8, right? So now I have come here, so I will say, okay, my this 30 is equal to a of 8, so I will return 2. Okay, so just in 3 comparison I have found this element 30. Okay, so if you compare with the linear search will take how much time? See, linear search will take order of n times. That means it will take a lot of time to find this 30. But here in this binary search, I have found the element in just 3 comparison. In linear search, it will take like total 9 comparison, 1, 2, 3, 4, until here 9 comparison will take place. But here 3 comparison, right? So basically, if you see, this binary search always decreases your search space by half, right? So let's say if your array size is 16, there are 16 elements. Okay, then next time your you can say your array will become half. That means either you will go this, either you will go this. So 16 half is 8. Then if you go here, let's say there are 8 elements, then next time you will just check for the 4 element, right? So your array size will become 4, in which you will search. Then your array size will become 2. Then your array size will become 1, and so on. Okay, so that means you will compare here, 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 this condition. Here. So how many time comparison will take place for 16? So you can say 1 time, 2 time, 3 time, 4 time, 5 time. For 16, 5 time, which can be written as 4 plus 1. Okay, if it is 32, array size is 32, then one more comparison will be there, that is 6 comparison, right? That means 5 plus 1. Okay, so I have told you in my video of the binary search that how this can happen, and I will tell you in the further videos that how we can actually go more in depth, that how we can find the time complexity of the binary search. But here you will see that it will take lesser number of time. Okay, less time to find or search a particular element. So basically this actually takes log n times, okay, or base 2. Okay, but how we can calculate this? We have various methods that I will show you in the further upcoming videos. Okay, so this is the time complexity, log of n. So you know n is greater than log of n, right? That means binary search takes lesser number of time. Okay, now let's move to the space complexity. So as you know, space complexity tells you that how much extra space you are taking in your main memory when you are solving your question. Okay, and you will not take the size taken by your original input when you are calculating the space complexity. Okay, so basically let's say this is your program, or you can say simple algorithm. Okay, and you know that when you are storing your you can say data in your program. Okay, so this is the memory layout of your program. Okay, so basically this program, okay, when it is converted to executable, the code part is placed in the code section. Okay, and the other datas, okay, other data, array, or you can say the variable, they will be stored either in data section, heap section, or the stack section. Okay, dynamic things are stored in the heap section. Okay, that I'm not going to tell you here. Okay, just for the introduction I am telling you. So basically this is the code, and if somebody asks what is the space complexity, so what he is asking like what extra space has been taken up by your code other than the original input. Okay, so if you see, we are taking this a and b from the user as the input, so these are the inputs. Okay, so we actually do not count, okay, the space taken by our original input. Okay, the extra things that we are taking, okay, to get our answer, that we take into account to tell you the space complexity. They contribute toward the space complexity. So before this, in general, where these data will be stored, see, this is static variable, this is like int variable. Okay, so these will go into the data section x, a, b. So x takes how much time, oh sorry, how much space. So all these are int type, so they will take 4 byte, a will take 4 byte, this will take 4 byte. Okay, so if you want to write, let's say, the space taken by them, okay, 4 plus 4 plus 4, these are in bytes, 4 byte, 4 byte, 4 byte. Okay, now plus, okay, this c is the extra one of the variable, so this will also be stored here. So c also takes 4 byte, right? There are no other variable. So if you take the space taken by all, this is 16 bytes. Okay, now if you see, if I let's say give a equal to 10, b equal to 20, then also there will be no like effect on the size of the a and b. A and b will take 4 byte. Let's say a is, let's say 10 for let's say 1000, and b is, let's say, a very big number, then also my a and b will take 4 byte. Okay, that means the input size, okay, that is not affecting the space taken by my this a and b, or it is not affecting the space taken by my program, right? So here in this case, okay, here in this case, everything is constant. It will take 16 bytes, okay, no matter what, how large the value of the a and b. So here we are saying, based on the input size, my space complexity, the extra space taken up by my code, is not changing. It will always remain 444, that is 16 byte. So to express this space complexity, I say the rate of change of space, okay, here it is constant, and to express constantness, I say order of 1, same as time complexity. See, these complexities are just telling you the rate of change of time or the space. So we are just expressing in just in this way only. Okay, I can say space complexity will be order of 1, right? So basically here everything is constant. Space complexity is based on constant space taken plus auxiliary space taken. Okay, addition of these two things constitute space complexity. So here everything is constant. Auxiliary space taken means extra space taken. Extra space already it is taken by c. Okay, so you can say this is the extra space. Okay, this is a, this is b, this is the x, but this extra space is also like not affecting any way. Okay, so here everything is constant. Now I will give you the another example. So here in this example, this is the function, and it is taking the array, one array, okay, as the input, and n is the size of this array, right? Okay, so if you see inside this code, okay, inside this code, here I have taken an extra array, b array. I have taken an extra array to solve my question. This is a array and this is b array. Okay, this is also of size n. Okay, so whatever the size of the original array is, I am creating a new array of the same size. Okay, so this is the extra space. Okay, extra variable I am taking. Okay, again this is the extra variable I am taking. Okay, what other variable I am taking? No, this is the this variable. Okay, so these are the three different variables I am taking. Okay, so I say space complexity. See, this array, this is a local array. Okay, taking the space here. Okay, some it will be stored here. Okay, okay, data section. Okay, or again it is a local variable. Okay, so you can just remove this. Okay, you can just remove this. Okay, they will actually go there. Okay, same in the previous video also. Okay, I just made a mistake. They will go into the stack section. Okay, they are the simple local variable. Okay, now this n, again n is also a simple, you can say, local variable. Okay, so it will also take 4 bytes. Okay, so this is 4 bytes, sum 4 bytes, and this b array, it will take how much space according to the value of n. Okay, you will say 4 bytes, n is 4 bytes, right? Okay, and b, see, this array size is dependent on n, so it will take n bytes. This b array will take n bytes. This is 8 bytes plus n bytes. You can say n bytes. So again, when you are calculating the space complexity, you actually remove the constants. Okay, this is the constant. Okay, 8 is constant. You can remove this. Okay, because if n is very large, array is very large. Let's say the size of the array is 1 lakh. Then in comparison to 1 lakh, 8 is very small, right? So you can neglect this. Okay, so we are left with n. and there is no other thing, other constant. Okay, so we can say space complexity is order of n. Here also you can say space complexity in terms of original input is order of n. Okay, so here my this uh, space complexity is dependent on n. If n is 1 lakh, I will create a 1 lakh size array. If my n is, let's say, 10 lakh, then I will create a 10 lakh size B array. Okay, so my extra space is being dependent on n, and it is dependent how? Linearly. Okay, so I hope you have understood the concept of the space and time complexity. More example we will see in the further videos, and we will be able to understand it better. Okay, before ending this video, just last one thing: time complexity and space complexity, they can be dependent on more than one input also. For example, in my program, let's say I have made a program. Okay, in that there are two inputs, n and m. N is the, let's say, size of one array, let's say A, and the other array is of size m. Okay, then I have two inputs, n and m. I have to express the time complexity in both of the input. So let's say if I'm saying this is the time complexity, then this is also valid. The same way, this is also a valid time complexity, n multiply m. Okay, there can be more than 2 input, 3 input, so on. The same way we can express the time complexity. The number of inputs are there. The same way, based on that, I have to express the time complexity. Okay, my space complexity is dependent on these two. Okay. Now the next thing that I want to tell you is, for example, if you are just given this O of n and somebody is asking, okay, this is a algorithm. Okay, some algorithm is there, and I have given you this thing O of n. Then can you tell whether it is a space complexity of this algorithm or a time complexity? You cannot tell. Why? Because space and time complexity both are expressed in the same way. So just by seeing this thing, you cannot tell. Okay, the same way if you are given this thing, okay, you cannot tell whether this is a space complexity or the time complexity. Okay, so time complexity and space complexity, for this you should be like explicitly told, okay, that this is a time complexity, okay, or this is a space complexity, okay, for this algorithm. Then that is like a meaningful thing. Okay, so we will see more examples in the further videos, and please do like, share and subscribe this channel, and press the bell icon for notification. Tell me your comments in the comment section. See you in the next video. Till then, goodbye.